Welcome students to the third lecture of mathematical reasoning. In the last lecture, we were discussing construction of new statements from old ones. So, first we have discussed negation. If P is a statement, then negation of P is the opposite of P in the sense that if P is true, then negation of P is false. On the other hand, if P is false, then negation of P is true. And we have illustrated with several practical examples. For example, once more, all even numbers are divisible by 2 we know its truth value is t, therefore, its negation, if I call it say p, then negation of p is equal to, it is not the fact that all even numbers are divisible by 2, or same as all even numbers are not divisible by 2, or we can write it as there is some even number that is not divisible by 2, or we can write it as that all even numbers are divisible by 2 is not true, or we can also write that all even numbers are divisible by 2 is false. And we know that such a statement is false. Therefore, if Q is true, then not Q is false. Now, the question comes, what is not of not P? we know that we have the following truth table. P not P. So, if P is true, not P is false, and if P is false, not P is true. Therefore, what is not of not P? Since not P is false, then not of not P is true, and here not P is true. Therefore, not of not P, that is negation of P, is false. Therefore, whenever P is true, negation of P is also true. Whenever P is false, negation of P is also false. So, we can see that P and have the same truth value or they are, we call them, they are equivalent. That means, whatever truth value P will have, the same truth value you will have with negation of P. We shall talk about more of equivalent relations later. After that, we were talking about conjunction and disjunction. We have discussed the truth values of conjunction of two statements and disjunction of two statements. So, today we will exemplify it with some simple example. Suppose in a class there are 10 students. A, B, C, D, E, F, G, H, I and J. And our statements are P, student got 95% in maths. And suppose Q is another statement, student got 95% in computer science. And R is a statement, student gets prize if he got 95% in both the subjects. Suppose the truth set for P is C, D, E, F, G. That means, these are the students who got more than 95% in maths. And Q, the truth set is E, F, G, H, only these 4. They have got 95% in computer science. Then what is the truth set for R? We know that R is true if a student obtained 95% in both maths and computer science. So, if we look at that, we can see that only these 3 students have got more than 95% in both the subjects. Therefore, AND is basically it gives you the intersection of the truth sets of the component statements. Since R is nothing but P and Q. P, student got 95% in maths, Q, student got 95% in computer science, R, student gets prize if got 95% in both the subjects. Therefore, R is equivalent to P and Q. So, let us look at how it works. Consider the 4 cases. A did not get 95%, therefore, A does not satisfy P. So, for A, P is false. A did not get 95% in computer science. Therefore, for A, Q is also false. Therefore, A does not get a prize, and therefore, for A, R is false. On the other hand, if we consider C, for this student P is true, but Q is false, and we know R is also false. For a student say like J, say H, consider H. For H, P is false, Q is true, because he belongs to the truth set of Q. That means that he got 95% in computer science, and if we look at it, then we know that he also does not get a prize. Therefore, R is false. Therefore, only persons who can get prize are somebody like E, for which P is true and Q is true. So, if we work out like this, we can easily understand the truth table for conjunction. Therefore, truth table for conjunction is something like this. P, Q, P and Q. If P is true, Q is true, then this is true. If P is true, but Q is false, then this is false. If P is false, but Q is true, then also this is false, and if both of them are false, then P and Q is also false. So, this is the truth values that we can determine for the compound statement P and Q when we have the truth values for P and Q given. Okay. Now, the question is, what is the negation of P and Q? Or in other words, if a compound statement is a conjunction of two elementary statements or two component statements, then what is the negation of the compound statement? So, in order to work out that, I will first look at the truth table for disjunction. I take the same example. I have 10 students A, B, C, D, E, F, G, H, I, J. I have the same truth sets for P is C, D, E, F, G. For Q it is E, F, G, H, and R is a disjunction of P and Q, or R is P or Q, that is a student gets prize if he gets 95% in maths or computer science or both. So, a student can get prize if he gets 95% in any one of maths and computer science, or if he gets in both of them 95%. Therefore, I can write R is equal to P or Q, in the sense that whichever elements are members of the truth set of P and whichever elements are the members of the truth set of Q, they all belong to the truth set of R. So, let us look at it. Consider somebody like A, for which P is false and Q is false, and he does not get prize, therefore, R is false. What about some student like C, for whom P is true, Q is false, and we know that R is true, because he gets 95% in maths and therefore, he gets a prize. Consider a student like H, for whom P is false, Q is true, and we know that he gets a prize, therefore, R is true. And of course, if we look at a student like E, for whom P is true and Q is true and R is true, because he gets 95% in both, therefore, he gets a prize. Therefore, what we can see in the truth table, if P is true and Q is true, then R is true. If P is true, but Q is false, still R is true. If P is false, but Q is true, then R is true. And if P is false and Q is false, then R is false. So, that gives us the rules for constructing the truth values for a statement which is the disjunction of two statements P and Q. Then we can find that corresponding truth values. If P is true and Q is true, then P or Q is true, and this is going to be the truth value. Now, what is negation of P and Q? Let us draw the set again. Okay. And we know that the truth set for P is C, D, E, F, G. So, P is true So, what is the negation of P and Q? Negation of P and Q we compute like this. P and Q is the set of students who got 95% in both maths and computer science. Therefore, these are the students who got prize. Therefore, what is negation of Q? Negation of P and Q? Negation of P and Q is the students did not get prize. And who are these students? If we look at the name of the students again, it is A, B, C, D, E, F, G, H, I, J, and we know that the truth set for P is C, D, E, F, G. And what is the truth set for Q? It is E, F, G, H. So, which are the elements who belong to that set? It is E, F and G. Therefore, these are the only students who have got prize. So, what belongs to not of P and Q? Not of P and Q is A, B, C, D, H, I, J. Who are these? A, B, I, J, they did not get 95% in any of the subjects. C and D have got 95% in maths, but did not get in computer science. H got 95% in computer science, but did not get in maths. Therefore, if we look at not of P, what is not of P? Those who did not get 95% in maths. So, the red rectangle gives us the students who got 95% in maths. Therefore, not of P, negation of P has the truth set A, B, H, I, J. What is negation of Q? It is the set of students who did not get 95% in computer science. And if the black rectangle gives us the students who have got 95% in computer science, then negation of Q or the elements, the truth values for truth set for that is A, B, C, D, I and J. What is the union? Or if we look at what is not P or not Q. Not P or not Q, we can now say that students who did not get 95% in either maths or computer science or both. So, not P is those who did not get in maths, not Q those who did not get in computer science. Therefore, not P or not Q is the students who did not get 95% in either maths or computer science. And therefore, what is not P or not Q? We can say it is the union of the individual truth sets, and therefore, it is going to be A, B, C, D, H, I, J, which is nothing but actually the set of students who did not get prize and therefore, they are nothing but negation of P and Q. Therefore, we can see that negation of P and Q and negation of P or negation of Q, they have the same truth set, or in other words, they have the same truth values. I look at it from a different way now. I will make a table and I will show you how it comes. So, consider P Q. We know that P and Q together have 4 different truth values T T, T F, F T and F F. We know that P and Q will have the following truth value. It is true F, F, F. Therefore, negation of P and Q will have the truth value. It will be just opposite of this. Therefore, it is going to be F, T, T, T. Then we know that negation of P is it is true, therefore false. It is true, therefore this is false. This is false, therefore this is true. This is false, therefore negation of P is true. Not Q will have the truth values. If it is T, then not Q is false. If it is false, not Q is true. It is true, therefore this is false. It is false, therefore this is true. Now, what is not P or not Q? Not P or not Q, therefore we will have the following truth values. It is true if any one of them is true, and therefore, it is going to be F T T T. And if I now compare these two columns, we find that negation of P and Q is equivalent to negation of P or negation of Q. So, it is the De Morgan's law. We can remember them as it is, or we can look at it from a set theoretic point of view, and we can compute very easily the truth value of negation of a conjunction. In a very similar way, we can compute negation of a disjunction. So, negation of P or Q. If we look at the second example, P or Q was basically saying all the students who got 95% in maths or 95% in computer science, they will all get prize. Therefore, those who did not get prize are the ones who did not get 95% in any one of them. So, we look at the example again, A, B, C, D, E, F, G, H, I, J, and I have the following C, D, E, F, G, and I have this one is the truth set of P, E, F, G, H is the truth set for Q, and we know that the only persons therefore who will not get prize are A, B and I, J. So, this is the truth set of not of P or Q. Now, what is not of P? Not or negation of P? Negation of P is A, B, H, I, J. What is negation of Q? Negation of Q is A, B, C, D, I, J, because these are the students who did not get 95% in computer science. Therefore, what is the intersection? We can easily see that the intersection is A, B, I, J, and we can see that this is same as this. Therefore, we can see that the truth set of not P and not Q is same as not of P or Q. So, this is the way we understand this. Let me again construct the truth table, and you will understand it very easily. So, truth table P, Q, true, 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 false, false, true, false, false, P or Q, we have T, 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 false, not of P or Q, this is false, false, false and true, because not of P or Q we will have the opposite truth value of P or Q, and we get this table. Now, what is not of P? Not of P is, we have T, T, F, F, here we will get F, F, T and T. Not of Q, we will have T here. So, this is F, T, F, T. Therefore, not of P and not of Q, this will be true only if both the elements are true, otherwise it is false. And so, it is false. F and F, it is F, F and T, it is F, T and F, it is F, and T and T, it is true. Therefore, what do we find? We find that this column and this column have the same truth values once the truth values of P and Q have been given. Or in other words, we can say not of P or Q is equivalent to not of P and not of Q. This is also De Morgan's law. Now, I give you two definitions. A statement is said to be a tautology if it is always true. A statement which is always true is said to be a tautology. Okay? Example, the simplest example is P or not P. We know that if P is a statement, it is going to take truth values either true or false. Therefore, if P is true, this is false, and therefore, T or F is true. If this is false, then this is true. Therefore, false or true is true. Therefore, P or not P is a tautology. On the other hand, a statement which is false all the time is called a contradiction. For example, P and not P. P is a statement which can happen, which may be true, which may be false. Not P, which may be true, which may be false. But the beauty is that when P is true, then not P is false, and therefore, T and F, we know that already, is F. And if P is false, not P is true, implies F and T is F. Therefore, irrespective of the value of the statement P, we can see that P and not P is always false. What does it mean? It means that the truth set for P and not P is empty. With that background, let me go to the next way of construction of new statement is called if then or implication. What is this? Something like this. If the sky is cloudy, then I take an umbrella. So, we can represent it mathematically in the following way. Let P be the statement the sky is cloudy. And Q is the statement that I take an umbrella. Let R is if P then Q. That is, if the sky is cloudy, then I take an umbrella. Therefore, if P then Q. Or symbolically, P implies Q. Now, implication is very interesting thing. We have to understand what exactly we mean by P implies Q. So, if sky is cloudy, I take an umbrella. Question: what if the sky is not cloudy? We cannot say anything from the above statement. What I will do if the sky is not cloudy? I may take an umbrella, or I may not. It is not clear, it does not say anything if the sky is not cloudy, or if I write it as P implies Q, it does not say anything about Q. On the other hand, we can say if I don't carry an umbrella, then that day the sky is not cloudy. right? Because if the sky is cloudy, then I am going to take umbrella, but I am not taking umbrella. Therefore, we can easily infer that the sky is not cloudy. Therefore, if P implies Q, then not Q implies not P. That you can understand logically from there. Okay? We can give many such examples. So, to illustrate, let me consider if x is divisible by eight, then x is divisible by 4. Or in other words, if P is the statement x is divisible by 8, Q is the statement x is divisible by 4, then we can say that P implies Q is essentially means if x is divisible by 8, then x is divisible by 4. Or a number, if it is divisible by 8, it will be divisible by 4. We cannot say anything if the number is not divisible by 8, because there are numbers like say 12, which is divisible by 4, but not by 8. Therefore, divisibility by 8 is not a necessary condition to be divisible by 4. There are numbers which are not divisible by 8, but divisible by 4. But if a number is not divisible by 4, it cannot be divided by or it cannot be divisible by 8. Therefore, not of Q implies not of P. Therefore, as I repeat, divisibility by 8 is not a necessary condition for divisibility by 4, but it is a sufficient condition. If some number is divisible by 8, then we are sure that it is going to be divisible by 4 as well. So, that is the interesting idea behind implication, and based on that we have to construct the truth table for P implies the best way to remember this is like this. We know that P or not P is always true, right. Now, P implies Q, therefore, whenever P is true, Q is true. Therefore, we can write it as Q or not P. Or in other words, we can look at it in the following way, that if P is the sky is cloudy, Q is I carry an umbrella, then one of the two will always happen. Either the sky is not cloudy, not negation of P, or I am carrying an umbrella, or Q. So, if we consider the truth values of P implies Q, it is sometimes easier to look at from Q or not P, or not P or Q. So, let us consider the truth values of P, Q. We have T, 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 F. This you have seen many times today. F, T, F, F. So, what is not of P? We have also seen it many times today. Whenever P is T, not P is negation of P is F. Whenever T is F, negation of P is true. So, negation of P has these values. Therefore, negation of P or Q will have the truth value. This or this is true. This is F, this is F. So, this is F. It is true or true, which is true, and this is F and T, which is true. So, this is Q or not P, and this is precisely the truth values of P implies Q. So, P implies Q, which is equivalent to Q or not P, has following truth value. If P is true and Q is true, it is true. That means, if the sky is cloudy and I carry an umbrella, then this implication, if sky is cloudy, then I carry an umbrella, there is no way to say that is wrong. This is true. If the sky is cloudy, but I am not carrying an umbrella, then the statement, if cloudy then umbrella, that is false, and therefore, T implies F is false. If it is false and it is false, then I have no way to reject that statement, therefore, it is true, and if it is false, but it is true, then it is also true. So, this is the truth table for P implies Q. We have to remember it for solving problems. So, question is, what is the negation of P implies Q? The best way of doing it is this. Just now we have seen. What is this? It is negation of Q or negation of P, which is by De Morgan's law is negation of Q or negation of P, and we have seen at the beginning of this lecture that this is P and this is negation of Q. So, the negation of P implies Q is not Q or P. Next, we will talk about equivalence. two statements P and Q are said to be equivalent if P is true implies Q is true and Q is true implies P is true. In the earlier case, if it is one way implication, if P implies Q, we have seen that if P is false and Q is true, then that is also true, but that is not the case with equivalence. So, we can write it as P and Q are equivalent if P implies Q and Q implies P. Both of them should simultaneously happen to say that P and Q are equivalent. So, what will be the truth table? The symbol for equivalence is P is equivalent to Q or P is implied and implies by Q, then we can write P, Q, P implies Q. So, T T, T F, F T, F F, this is going to be T, F, T, T. What is going to be Q implies P? If both are true, then this is true. If Q is false, but P is true, then this is true. But if Q is true, but P is false, then this is false, and when both of them are false, it is true. So, they are equivalent, then we have to AND them. Therefore, P equivalent to Q will have the truth value AND of T and T, which is T, AND of false and T, which is false, T and false and is false, and T and T is T. Or in other words, if both of them are true, then we can get P is equivalent to Q. If both of them are false, then we can get P is equivalent to Q, otherwise it is going to be false. Okay, friends, I stop here for today. In the next class, I shall be dealing with a few more definitions, and then I shall be solving a few problems with respect to mathematical reasoning.